All right. Well, it is good to see everybody. So, as I said, I've got 2 items on the agenda for today. One, we'll go ahead and start with that quiz from yesterday. If you have any questions, I'll go ahead and try to answer those as best as possible. And then 2, I want to go ahead and finish talking about the natural number. So remember, earlier this week, we did finish talking about how to solve exponential equations using logarithms. That assignment is going to be due on Friday, and I didn't put it out because I was in pre-cal before this, but I'm going to go ahead and give you an assignment for the natural number as well, because we're going to finish that today, and then I'll go ahead, we'll talk about that on Friday as well. So tomorrow we'll go into compound interest. We'll continue that into early next week, and then majority of next week we'll talk about parabolas, and then what's happening on Tuesday the 13th. Post-test, yes, got the post-test. Okay, so yes, after the post-test we have one more lesson, but that's super cool. You know, something to send you off into your summer with more mathematical knowledge. Oh, you agree we should? All right, you heard Jackson. Okay, he said we should do it. All right. Okay, so here is the quiz. What do we want to talk about? 4. Okay, let's take a look at 4. All right, so we got log base 4 of k squared plus 2k is equal to log base 4 of 60 minus log base 4 of 4. So remember, you can only cancel out the logs if it's a 1 log equals another log style equation with the same base. So here we have more than 2 logs, so I've got to condense this right side. But what do we do if they're being subtracted? We divide. So this is going to be log base 4 of k squared plus 2k is equal to log base 4. Now, because the 60 is first, it would have to be the numerator. So 60 divided by 4 is 15. Okay. So now that it's a log equals log, I can cancel those out. And I can say that k squared plus 2k equals 15. And then we just go ahead and kind of solve it that way. Let me go ahead and subtract the 15 over. So I'm going to have k squared plus 2k minus 15 is equal to 0. Okay. So I got myself a quadratic. So we'll go ahead and factor this. What 2 numbers will multiply, give me negative 15, but add to give me positive 2? Okay, 5 and 3. Which one's the negative? Okay, it has to be x plus 5 and x minus 30. Okay, and this is actually good review for what's coming up the week after next. So if I am looking for the roots or the zeros of a quadratic, factoring is a great way to do that. How does that help me get my answers, though? Remember, we got to set them equal to 0. That's what we call the zero product property. So if x plus 5 is equal to 0, x equals negative 5. And if x minus 3 is equal to 0, well, then x equals 3. Now, the one thing you really want to be careful of when dealing with logarithmic equations, the argument, what's in parentheses, cannot be what 2 things? Can it be negative or a 0? Okay, so if I go ahead and take the 3, if I plug it in here, 3 squared 9 plus 2 times 3, that works out fine. Those, there's nothing to plug in here. So the 3 is good to go. I mean, you can definitely go ahead and check to see that it works, and it does. Now, I think this is where some people accidentally made a mistake. What happens when you square a negative number? It becomes positive. So that would be a positive 25. Now, the 2 times negative 5 will give me minus 10, but see, that still turns out to be a positive. So both the negative 5 and the 3, they do work. And I believe, yeah, that was the only one on there that had multiple answers. Okay. What else? Do 2? Let's do 2. Okay, so same type of problem. Now here, they're separated by addition. So what do I do if that's the case? We're going to multiply. So we've got the log. 12 times 5 will give me 60 is equal to the log 4m plus 8. Okay. Quick question. There's no base, so what is that? That's base 10. That's the common log. Okay, it's log equals log. We can cancel those out. So I got 60 is equal to 4m plus 8. And then now it's just a matter of solving for m. So the first thing I would do is subtract. I got a 52 is equal to 4m. And when I go ahead and divide, that is 13.
Wait, bro. I put m equals 13 when I answered it. When I put it on 552, for some reason I put m equals 8. Look, I got it m13, but then I don't know where the hell the 8 went.
Where did 8 come from?
I don't know, because look, I got it here.
Okay.
Oh my god.
So I'll tell you what, remind me about that at the end. I'll get you those points back. All right. Yes. Oh, actually, Survey should ask first. Are you ready to go?
Yeah.
Well, do you still need to go?
I had it. Yeah, I had it.
Okay, so we should be after you. Okay. You got your badge. Okay. All right. What else?
Well, I don't
Any other questions? Yes. Number three. Okay. Now this one. Okay. It looks like it's already a log equals log. Okay, but we can't cancel out the logs just yet. What am I missing? That 4. So there's nothing to condense but a coefficient. Remember, I can make it a power inside of that argument. So this is going to be log base 7 of 9p minus 5 is equal to log base 7. So if this becomes 2 to the 4th power, that means that argument is now 16. So now we don't have any coefficients. It's log equals log. I cancel those out. If 9p minus 5 equals 16, then that means 9p is equal to 16 plus 5 is a 21. Let's go ahead and divide through. Now, it won't divide evenly, but it can reduce. They're both divisible by 3, so it would be 7/3. Was that it? Was that the 4? Oh, okay. So you remember to put it on the argument, we just got the wrong value? Oh, that's good. Okay. All right, anything else? Okay, sounds good. We're going to go ahead. Let's put those to the side here. Let's pull this out. Does anybody need a copy of the notes? So let's see. We should be able to get this done by 57. No, we got it 4. 5th period is 57. Let's see. If we're going to be in here until 12:57, we'll definitely be able to finish that. Okay. So I know that Rowdy's going to keep moving. But anybody else need a copy of the notes? Yes. Okay. Well, cool. So we started talking yesterday about E. This is what we refer to as the natural number. It is an irrational number who has value of 2.71828. So typically people go ahead and say 2.718 when they're referring to its value. You know, very similar to when I say pi, you'll probably immediately think 3.14. Okay. It's also an irrational value. Okay, so if we're talking about an exponential, E is what we call the natural base. We'll go ahead and highlight this. Okay, so it is a growth base because 2.718 is greater than 1. If we're using E as a base in a log, it's what we call the natural logarithm. Now, we talked yesterday that this right here, log base E of x, that is technically correct to write, but the mathematical community at large, we don't like to write it that way. E is so useful and such a special number to us that we went ahead and gave it its own notation. Okay, so it's like a moment ago when I asked you, hey, there's no base there, what is it? You recognize that it's 10, the common log. Well, if you see this notation, Ln, the natural log, we're dealing with base E. Okay, and this is where we got to yesterday. We went converted from exponential to logarithmic and then logarithmic to exponential. Did anybody have any questions on those? Okay. All right. Well, now we're going to get into the properties. So it's the same idea. So I can go ahead and give you some examples over here. Let's say I have log base 3 of 2x. Okay. If I'm multiplying inside a log, how would I separate those terms? Would I add or subtract? We're going to add. Let's say if I'm multiplying inside of an argument, we can separate those by addition. So this is going to be log base 3 of 2 plus log base 3 of x. Okay. Remember, that's what we call the product property. Okay. If we're dividing, let's say if I were to have log base, I'll say 5 this time. I'll just use the same terms of 2 over x. Okay, so if we're multiplying in an argument, we separate by addition. But if we're dividing, what do? We use subtraction. Okay, now with the numerator going first, so this would be log base 5 of 2 minus log base 5 of x. That's what we call the quotient property. Okay, and there was one more that we call the power property. So if I had, like, let's say log base 7 of x squared. Okay, if a term in the argument has a power, where can I put that power? I can pull it to the front where it's a coefficient. So this would be 2 times log, that's a log, base 7 of x. And remember, all of these are reversible. I can expand a log or I can condense a log expression. Okay, now the fact that we have this natural log right here doesn't change a thing. These rules are still going to apply, it's just we know we're dealing with base e. Okay, so for example, in number 7, the natural log of 3 plus the natural log of 16. Because they're separated by addition, I'm going to multiply these two. That would simply be the natural log of, what's 3 times 16? 48. That's all there is to it. Okay. So the natural log doesn't change anything. It's just a brand new base. We've got natural log of 63 minus 2 natural log of 3. Now, we know the subtraction, what am I going to do? I'm going to divide, but before I do that, there's something I got to take care of. The 2, remember, any coefficient, we're going to go ahead and put it back and make it a power. So if I have 2 cubed, that's going to give me what? Ooh. Oh, I said, I put 2 as the base, silly me. That should be 3 squared. So it should be what? 9. Okay, so now I've got the natural log of 63 minus the natural log of 9. Okay, so when I go ahead and divide these, 63 is first, so it has to go in the numerator. So the natural log of 63 over 9, and what is that? The natural log of 7. There you go. Okay. Same exact properties we've looked at, it's just new notation. Okay, so nothing different. All right. So with what we've done, take a few seconds, bless you, try number 9 for me. Okay, if you haven't already done so. Okay, so we've got 1/3 the natural log of 64 plus 2 the natural log of x. There you go. Perfect. Oh, yeah. Okay, what we got? Oh, you were right here.
Oh.
No, we don't have to do anything else today. Not unless there's some power that we also still have to work with. There you go. Yeah. Perfect. Okay, well, the first thing we're going to do is take each of these coefficients. We're going to apply them as powers. So we've seen this quite recently. Anything to the 1/3 power, that's equivalent to what? taking the cube root. And what is the cube root of 64? Okay, so this is going to be the natural log of 4 plus the natural log of x squared. The plus tells me we're going to multiply, so the natural log of 4x squared. Okay. Now, I'm not going to go ahead and split hairs. If you go ahead and write it like this, log base e of 4x squared, I mean, that's still technically correct. Okay, the preferred notation is going to be the LN, but just be aware you may run across a professor or a teacher who's going to be really, strict about that. I had one, I think I already told you folks this story about the one teacher, when you rip it out of a spiral, if it has those little paper ends on there, if you turned in a paper with that, she wouldn't even look at it, she threw it in the trash. So, yeah, it's me too. That's why I just would turn it in. Yeah.
Wait, this actually happened to me with Mr. Perry, like my. Yeah. No, like. Yeah, you give us like a
Okay.
piece, which I 2 times I wasted, so I made my own, which he did not accept. So if I don't come near him like in 10 seconds, he's gonna throw it off on the trash can, and I do go like enough this time limit.
Oh.
Throw it in the trash.
Oh.
You made it.
Oh, so you made it. Yay. Yes, when Reese gets back. You want to blow your nose? Yeah, go for it. All right. So let's take a look at number 10. So this next set here, we want to go ahead and expand each log. Okay. So we're just reversing the process that we were looking at. This one here, we've got the natural log of 5x. How do I separate if we're multiplying? We go. We add. So the natural log of 5 plus the natural log of x. Okay, if you are multiplying inside an argument, you separate those terms by addition. Remember, each term gets its own log with the same base. In this case, the natural log. Now for 11, we're dividing, so we already know that means subtraction. There's something I need to do before I do this. There you go. See, I want to go ahead and simplify the argument. So this is going to become the natural log of a to the what? A to the 6th over b squared. Is everybody okay with that? Okay. Now I want to go ahead and break it apart. So this is going to be the natural log of a to the 6th minus the natural log of b squared. And I can't help but feeling that there's something else I need to do. Yeah, if you're expanding it, any power, you want to make sure to pull those to the front where they become coefficients. That's our power rule. So my final answer would be 6 times the natural log of a minus what? Minus 2 times the natural log of b. There we go. Let's see, Jackson was going next, and then you'll be after him. All right. So let's try 12. Walk me through this one. So we're multiplying, so we're definitely going to break it apart by addition. But I want to take care of that cube root. Now, we just saw the cube root is equivalent to raising it to what power? 1/3. Okay, so let's look at it like this. Let me go ahead and get this out of the way so I have some room. Let's just focus on the argument. So we right now have the cube root of m squared n. So let's go ahead and rewrite this as m squared n to the 1/3 power, because that's equivalent, right? Okay. But now let's go ahead and simplify this. Let's distribute that power to each of my terms. So it looks like I'm going to end up with m to the what? M to the 2/3 times n to the 1/3. Is everybody okay with what I did? Okay. So now I've got the natural log of m to the 2/3 times n to the 1/3. Okay. Now we know we're going to break this apart by addition, but we're also going to have to do what? Pull those fractions to the front. So what do you like? Anybody like me to write this in 2 steps, or can I just go straight to the answer? Everybody's okay with that? So we should be getting 2/3, the natural log of m, that's an m right there, It's a horrible m. Plus what? 1/3 the natural log of n. There we go. Anybody having a hard time? Anybody lost? Okay. Cool. All right. Well, here's our last section. Okay, solving equations. Okay, now, big idea we don't want to forget. The argument of a log, even a natural log, cannot be negative or zero. Okay, so it's the same style equations we've been looking at previously. It's just now we have the natural log. Okay, so I chose some of these specifically. We'll start skipping around in just a second. Let's start with 13. The natural log of 4x minus 27 equals the natural log of 15 minus 2x. Okay, well, what do we notice? Yeah, isn't it already log equals log of the same base? So I can cancel those out. I can immediately say that 4x minus 27 equals 15 minus 2x, just like we saw a few moments ago, just like yesterday. Okay. So let's say I want to add the 2x over. We can do it. So 6x equals. So at the same time, let's add the 27. So what's the 27 plus 15? 42. Insert you, life, the universe, and everything. I don't think there's ever a time I can see that number and not think that. So x is what? X is 7. And if we go ahead and plug it in, 4 times 7, 28 minus 27, so that would be the natural log of 1, equals 15 minus 2 times 7, so 15 minus 14 would also equal the natural log. So not only does it make both sides equal, no argument becomes negative or 0. Okay. So it's only extraneous if it does not work. Okay. Well, this is easy. So I guess right here I can just go ahead and say that k equals 2k plus 15. There we go. Before I can do that, we have to apply that 2 as a power. So the natural log of k squared equals the natural log of 2k plus 15. Now that it's a log equals log, cut them loose. Okay. And I like to keep the squared term where it is. So if k squared equals 2k plus 15, well, why don't we go ahead and subtract those other two terms over? So k squared minus 2k minus 15 is equal to 0. All right. So let's see. We know it's got to be a 5 and a 3. We saw a version of this earlier, but this time it's got to be negative 5. So it's going to be k minus 5 times k plus 3. Oh, just run over there by the flash, please. I'll take care of it. Okay, and then we go ahead and set these equal to 0. So it looks like I'm getting what two solutions? Looks like positive 5 and a negative 3. Okay. Now, will both of those work? Okay, why not? There you go. See, I got to be able to put it back in the original, so it's because of this term right here, 2 times the natural log of negative 3. See, that can't happen. Okay, so the only answer on this one is 5. So the negative 3 was extraneous. Yes. Yeah, let's back. All right. Anybody having a hard time? Anybody lost? Okay. Well, let's start skipping around because basically you already know how to solve these equations. We're just now looking at them with a natural log. Let's go to 16. Okay. So I've got 2. Natural log of m plus 4 equals the natural log of 4. Bless you. Okay. So what do I do? Okay. So I've got to take this coefficient. Now I've got to square the whole binomial. So that means I'm going to have the natural log of m plus 4, that quantity squared, equals the natural log of 4. Now I can go ahead and cut loose the logs at this point because I don't need them anymore. Log equals log of the same base. They're gone. Let's go ahead and expand this. So that would be m squared plus 8m plus 16 is equal to 4. Okay. Does anybody want me to go back and show how I expanded that? I just kind of went and did it in my head. Okay, so let's take a look. So when you're squaring something, of course, you're multiplying the base times itself, right? So let's take m plus 4 and say m plus 4. Okay. So remember, what was that acronym we used to use? We haven't heard it in a while. FOIL, first, outside, inside, last. Okay. So let's multiply the first. M times m is m squared. 4 times m, that's 4m, that's the outside. Now when I multiply the inside, that's an additional 4m, and see those together, that's where I get the 8m. And then when I multiply the last, that's where I get my 16. Also, it has been an incredibly long time since we looked at this. Does anybody remember the rhyme? Square the left, square the right. What do we do to the middle? Starts with a D. Multiply by 2. Not distribute. Double. Double. Okay, square the left, square the right, double the middle, answers inside. Surely I told you that in the first semester. What? I could have sworn I did. It has been a while. Okay. All right, so let's go ahead and subtract this. So I'm going to have m squared plus 8m. 16 minus 4 will give me a plus 12. Is equal to 0. Okay. Two numbers that'll multiply to give me 12, but add 2 give me 8. 6 and 2. M plus 6, M plus 2 equals 0. So what are my two solutions? Okay, so remember, if we set these equal to 0, we get negative 6, and we get a negative 2. Okay, now one of them will work. Because let's think. Let's say negative 6 plus 4. See, that's a negative 2. So an argument is negative. We can't have it. There we go. But if I plug in a negative 2, negative 2 plus 4, that's a positive 2. So that is good to go. Okay, so you just want to be careful about that. The argument itself cannot be 0 or negative. All right. Well, let's go ahead and look at one last style of problem before we call it quits today. Let's look at 17. Now this one, it's not log equals log, but we've seen equations like this before. Natural log of 8x equals 2, what would I do? There you go. This is log. If it only has the one log, change it to an exponential, convert it. Okay, so what base do we have with natural log? So this is base e to what power? 2. Because remember, whatever log you write, it equals the power. That's what a log is. And then, of course, the base to the power would equal the argument 8x. Okay. So how am I going to solve this? Like, what would I do to get x by itself? I divide by 8, right? So what I need to do is figure out, okay, what's e squared, and then just divide that by 8. So this is what we're going to do. It's going to come on over to the calculator, which I do not have up. Okay, give me 1 second. La, 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 la. Okay, here we go. All right, so let's go to my calculate screen. Now you can do this all together, or you could just go ahead on the left side over here. Normally you go ahead and hit Control and then e to the x to get the natural log. Okay, but here I'm just going to go ahead and put that button without the control, and it gives me e to whatever power I want. So e squared is this, and then all I got to do is divide it by 8. Okay, so let's say I'm getting a 0.92. Okay, a 0.92. So I'm going to come on over here. That is the wrong one. Okay, so x is about of 0.92. Now, even if in the calculator you've gone ahead and plugged in the entire thing, like control divide, like I like to use a fraction, I'm going to go ahead and put in e squared divided by 8. You could do it all at once. Still going to give you what you want. Just whatever you feel most comfortable with. Okay. All right. Are these starting to make a little more sense?
Yeah.
Okay. So I'll tell you what. This is how we're going to end today. Go ahead. Try number 18. The natural log of x minus the natural log of 9 equals 7. So I'll tell you, this is going to be a decimal. Go ahead and round it to 2 decimal places. This will be the first thing that we go ahead and do when we come in tomorrow, and then we'll go ahead and get into compound interest. All right, yes. We get out of what, 57? Why do I keep looking at the wrong one? Okay, I keep looking at 5th period. Yes, 1204. Yeah, we should have enough time. Good Lord. Well, that means we could probably even go ahead and do a few more problems. Unless we just want to stop for today. I guess we should. Okay, I did say that. All right. So number 18, try number 18. We will talk about that tomorrow.